Are there any questions on the homework? Questions on the homework assignments?
Yes, or 35. I don't know how to plug
Number 35?
because I said unheading,
Mm-hmm.
but it just said like error or something.
Did you make sure that those were both minus or negatives and not minus?
Yeah. I tried to catch the door. I'm sorry.
You're good. Yep, because we do it here. Alpha y equals enter. Negative parentheses 3 plus.
Oh, what?
Yeah, plus.
What did I do? Oh, that's there. I forgot to add the plus because I was like.
Second square root. Because we can't do plus and minus. Because we have to do one and then the other.
I just didn't add the plus because like, I didn't know what to put for that. So.
Mm-hmm. Mm-hmm. Yep. That's it. Any other questions on the homework? All right. What we're looking at today is inequalities. Inequalities. And the first few we're going to look at is exponential inequalities. Now, the nice thing with exponential inequalities is that they solve almost exactly like exponential equations. And there are no restrictions. There's nothing that we have to worry about with these here. So when we look at 3 to the x is less than 20, we need to get the x out of the exponent. We need to get that 3x by itself. It is already by itself. So our main focus is getting the x out of the exponent. And to do that, we can apply log base 3 to both sides, just like we would with solving an equation. Now our log base 3 of 3 to the x is going to become what? Almost. Just x, our exponent. If it had been 3 to the 3x, yes, it would indeed be 3x. Because our log base 3 of 3 is 1, so all that's left is the exponent. It is less than log base 3 of 20. Questions on this so far? Now, log base 3 of 20 will not reduce nicely, so that's it. Questions on this so far? And the next one, e to the x is less than 2. And again, our first main goal is to get the e to the x by itself. Well, it already is. So we can apply our log to both sides. Specifically, what log? We'll apply the natural log, ln, to both sides. Because our ln of e to the x is going to become x, yes, is less than the natural log of 2. Natural log of 2, natural log of anything but e is not going to give us a nice number. Natural log of e is nice. It is 1, but anything else is not. So here x is less than the natural log of 2. That's it. Because the natural log of 2 is a number, but we're not going to focus on trying to do that. I just want us to solve it for x. Questions on this here? Last one of the exponentials that we're going to solve. 10 to the 2x minus 6 is greater than 3. What can we do first? So we can do log base 10, which is just log. Because our log, the base is understood to be 10, so we don't have to write it. It's not wrong to write it, but because the base is 10 with log, we don't have to. And that means our log base 10, or log of 10 to the 2x minus 6, reduces to 2x minus 6 is greater than log of 3. And all the ones we've done so far, this has been it. But is x by itself? No, so we just need to solve for x. And our first step would be to add 6 to both sides. Negative 6 plus 6 is 0, telling us 2x is greater than log of 3 plus 6. And lastly, we would divide by 2. Telling us x is greater than log of 3 plus 6 all over 2. Yep. And that's it. Because we could type that whole thing into a calculator and get the decimal answer. But again, that is the final answer for this here. Questions on this here? For the most part, this isn't any real different than what we did with solving, except instead of having an equal sign, we have an inequality sign. We good with these here? All right. Now, solving logarithmic equations do have a little bit of a difference to them. And it comes with the fact, or comes from the fact, that what's inside the log, this x cannot be 0 or negative. So with these inequalities, we do have to solve another statement besides the one we're solving. What's inside the logarithm has to be greater than 0. So here, x has to be greater than 0. And then we would solve for x. All right? So what would we need to do to get x by itself there?
Divide, maybe?
It's kind of a trick question, isn't it? Because it's x by itself. So we don't have to do a thing to it. Because if it wasn't, if it was x plus 9, then we would need to subtract the 9 and go from there. But for this here, our main restriction is that x has to be greater than 0. So we have that and we set it to the side. We will keep it there for now. Because if we solve this log, and it does come into play that we do have values of x that are less than 0, then we have to put that back in. But if our solution told us that x is greater than 12, doesn't matter. All solutions greater than 12 are also greater than 0. We don't need it. So we'll come back to it. So let's actually solve the equation they gave us. Telling us that log of x is less than or equal to 2. Well, what's the first thing we need to do to solve?
Log 10x.
Yep, because we need to put both sides to the base of the log. In this case, that's 10, because log, or 10 to the log of x, our 10 and log would cancel out, telling us that we have x by itself is less than or equal to. Is 10 squared a nice number? 10 squared, 10 times 10 is 100. So we can reduce that. We can simplify that. Well, x is by itself now, yes? X is less than or equal to 100. Does our restriction that we have earlier matter, that x is greater than 0? It kind of does.
X is greater than 0?
So x has to be greater than 0. And our final statement down here is saying what? That x has to be 100, yes? So it is right. This is fine. So this part's fine. This part's fine. But we're saying that x is all the values less than or equal to 100, yes? Is negative 2 less than or equal to 100? is negative 2 less than or equal to 100? Yeah, so that is a true statement, yes? But what did we say x had to be also? Greater than 0. So negative 2 is not greater than 0, but it is indeed less than 100, yes? So what we have to do is that's where this comes into play. Because if this statement is involved with this here, the fact that numbers less than 0 are included, or less than that restriction are included in this part of the statement, our x is less than or equal to 100, we have to add that back in. We have to prevent values that would cause the number inside the log to be 0 or negative from being part of the solution. Does that make sense? Now, if we'd gotten a statement, I'm going to add a new page here. We solved it and said x was greater than or equal to 100. Does it matter that x is also greater than 0? No, because all values of 100 are greater than 0. So I don't need this statement anymore. This is our final answer. But because the previous, or the one that we were doing that said that x has to be less than or equal to 100, it includes all those negative values. So we had to add the fact that it had to be bigger than 0. We had to add that back in. Does that make sense? So it's not always necessary, because I mean on the first one, uncircle that, if we just put in that x is greater than 0, or 0 is less than x is greater than 100, that makes no sense. We can't have those arrows going in the wrong directions. So that's just meaningless. Here it's just that. So we're good with that there. Now, log of x plus 9 is less than 45. So what's inside of our logarithm? Because x, yes? It is just x. That's the reason I asked that, is to see. Now, if it had been x plus 9, then it would have specifically put parentheses around the x and 9. I don't like this notation where they don't just write it as log parentheses x, close parentheses. But if both of them are contained inside the log, we would put parentheses around both. That makes sense. We're going to treat it like this here, because I do want us to see one where we have the parentheses, we have something more than just x inside the log. As if we left it alone as it was, our restriction for what x has to be greater than would just be like the previous one, x is greater than 0. So here we're modifying it a little bit. We're just saying that x plus 9 has to be greater than 0. Yes? Is x by itself? No. No. So we have to subtract 9, telling us that x has to be greater than negative 9. And one good way to make sure, kind of once you finish solving, if our solution has x is less than a number going towards that other restriction, we add it back in. If we finish solving this and it says x is greater than whatever our value is, then we don't need it in most cases. Now, what would we need to do first to solve it? Log of x plus 9 is less than 45. Almost. So since it's contained, we're going to put both sides of the base of 10. Now, if we didn't have the parentheses, it was just log of x plus 9, then yes. Because the base here is understood to be 10. Whenever we have log and the base is not written, it's understood to be 10. It's what we call common logs. The common log. Now, putting it to the base of 10 with our common log would cause it to cancel out, leaving us with x plus 9 is less than 10 to the 45th. The calculator can tell you that it is 10 or 10e to the 45th or 1e to the 45th.
1e 45th.
Yep. So it's not a nice number. So we're just going to leave it. Minus 9 from both sides, telling us x is less than 10 to the 45th minus 9. Do we need our restriction? Because it's 10 to the 45th minus 9. Because x is less than it, yes? Is our negative 9 less than 10 to the 45th minus 9? Because negative 9, whatever this is a massively big number, yes? Would negative 9 be less than whatever this number is?
Yeah, sorry.
Yeah. Since it is, we have to take this restriction, mainly this part of it. I'm going to draw right over the top of it. And put the negative 9 is less than x is less than 10 to the 45th minus 9. But that's it. That's our final answer. Because 10 to the 45th minus 9, I believe, would have 40 or 43 nines and then a 1. Yeah, so it's a 45 digit number. It is massive. Questions on this here? They feel comfortable with these here? Now let's look at this one here. Now, what's inside the log, we're not going to really mess with that one here, is just x. And we're saying that it has to be greater than 0. So our values of x have to be greater than 0. Now we need to solve this here. What can we do first? Because we need the ln by itself before we can do our bases.
We had to. Oh, subtract one?
Because our negative 1 plus 1 would be 0, telling us 2 times the natural log of x is greater than 5. Then what would we do to get ln by itself? Divide by 2. Because here our 2 and 2 would cancel, telling us the natural log of x is greater than 5 over 2. Lastly, we would what part?
That part.
Dividing by 2? We want to get
Oh, it's natural log.
by itself. So the first thing we would need to do in getting it by itself is to add 1, because it's being subtracted from 1. Because our negative 1 and 1 would cancel, leaving us with 2 ln of x, and 4 plus 1 is 5. What do we need to do next to get ln by itself? Because our 2's would cancel, telling us that the natural log of x is greater than 5 halves. And what do we do next? How can we get rid of the ln? Because these would, telling us x is greater than e to the questions on this here. Now we're saying all values of x have to be bigger than e to the 5 halves, yes? No? We can check that on a calculator. We can say second ln gives us our e to the 5 over 2, which is 12.1824 going on. So all the values of x for the solution have to be bigger than this, yes? Does it matter that x also has to be greater than 0? No, because all the values of x are going to be greater than 0. So for this here, I don't need that other part of the restriction because it doesn't matter. Those values that would cause us to have a 0 or negative inside of our log will never occur because all the values of x are greater than it. That work for this here. Questions on this here? We feel good with these. Well, I did have other ones listed, but I feel like those are probably going to get us more confused than help us. So we're just going to move on to the assignment. So you do have the rest of the time to work on this here.